All right, section 8.2, we are going to talk about factoring trinomials when our a value is -1. Now, I'll explain what that means in just a minute. Before that, a quick recap with product sum puzzles. So when we have these little boxes, like right here, we're trying to find two different numbers that multiply together to get the top number, and they also add together to give us the bottom number. So for this first one here, they're numbered 16, 17, and 18. But for the first one, we know it'll have to be, these two numbers have to be factors of this number because they have to multiply. Well, in this case, it's actually pretty easy. The only factors of 5 are 1 and 5. And if we multiply those, we get 5. And if we add them, we get 6. So that's our answer for that one. For 17, our product has to be -8, but our sum has to be +2. So if our product is negative, I know that one of my factors has to be negative and one will be positive. And if I look, or I think about the factors of -8, I'll think of 4 and 2. And if I add those together, when 2 is negative and 4 is positive, that will give me +2. And they multiply to -8. And then for the third one, two numbers that multiply to 9 but add to 6, that would be 3 and 3. Now, the standard form of a quadratic trinomial. So there's a lot of fancy words, but basically our standard form is going to look something like this. ax² plus bx plus c. Now, with these numbers, I know, or with these letters, I know it can get kind of confusing. All this means is there will be some coefficient in front of x², some coefficient in front of x, and then some number here. But today in this section, we are going to talk about trinomials, which this is a trinomial because I have 3 terms in it. We're going to be talking about trinomials, specifically ones where this a value is just 1. So I could even simplify it. If I know a is 1, then I will just have x² plus some number times x plus some number c. Okay? So with that, we can actually get a little cheat code for these product sum puzzles. So I'm going to redraw a product sum puzzle. Now, if a is 1, then for my product sum puzzle, the two numbers that my factors need to add to is going to be equal to whatever number is in front of x. So in this case, whatever number represents the b value is going to be the number at the very bottom of my product sum puzzle. My two factors have to add to the b value. Similarly, the two values, my two factors, are going to have to multiply to whatever my c value is. So when we are factoring, we want to make sure that when we look at our trinomial, and we're going to get to some in a sec, once we find our two factors, they will multiply together and equal whatever this number is, and they will add together and equal whatever this number in front of the x variable is. And we know that the number in front of x² for these problems is always going to be just 1. So, with all that being said, let's actually look at some examples. So, looking at example A, I have n² plus 16n plus 63. So, notice with all these examples, my leading term, where it's either n² or x², whatever it is, there's no number in front of it. There is no coefficient. Just like I said, that's because our a value is 1. So that number that comes in front of our first term, we're saying is 1, so we don't need to write it, because 1 times anything is just that thing. So just wanted to point that out. So for our first example, I'm going to start by writing my little product square. Now, what are the numbers that go in here? Well, I said this number, the number that my factors will add to, is my b value, which in this case is 16. All right, 16, and I got that from my b value. And then the number that they will get, the product, will be 63, because that is my, oopsies, need my highlighter. That is my c value. So whatever two numbers I choose, they have to add together to get me 16, but they need to multiply together to get me 63. So we need to figure out what are those two numbers going to be. Well, if they multiply to 63, they need to be factors of 63. So if we quickly try and figure out some factors, we get 1 times 63, we get 3 times 21, and then we get 7 times 9. If we do some trial and error, we will learn that 7 and 9 are the two numbers that we want. So in our answer, we are going to have two sets of parentheses. They will both begin with our variable to the first power. So in this case, our variable is n. So both my sets of parentheses will start with n. Then I'm just going to fill in each of these parentheses with both of these numbers. So first I'll have a positive 7, so n plus 7. And then over here I'll have my other factor, which is positive 9. Now we can check our answer if I distribute and see if I get my same original expression. So n times n would give me n squared. N times 9 would be 9n. And then I would add that to n times 7n. So 9n plus 7n gets me 16n. And then lastly, 7 times 9 would get me 63. So you can always distribute your answer to see if you get your original expression if you're trying to check your work. Okay, let's get some more practice. So this one, there's not as many numbers. So I'm gonna again start by writing my, I am not an artist. My product square. So the numbers that I need to multiply for are represented by this number here, and I'm going to make sure I have the proper sign. So in this case, they will multiply to get me negative 12. I keep forgetting to go to my highlighter. And they're going to add together to get me my b value, but I don't have any number in front of x. So in this case, my b value is just 1. And some more highlighting. So it's technically a 1. So my two numbers have to add together to get me 1, and they have to multiply together to get me negative 12. So if my product is going to end up being a negative number, I know one of my factors is automatically negative. So I'm just going to write a negative sign for one of them. So now I need to think, what are factors of 12? Well, I have 1 times 12, 2 times 6, and 3 times 4. So 3 and 4 look like the proper ones. We just need to figure out which one's negative. Well, if my sum is positive, then the larger number of these two has to be positive. So in that case, we'll have positive 4 and negative 3. Now, setting up our parentheses for our final answer, my variable is x, so I will begin both of them with an x variable, and then I'll just fill them in with my two factors. So x plus 4 and x minus 3. All right. Go ahead and try problem C. All right, I got my final answer to be x minus 1 times the quantity x plus 4. I got my two factors to be negative 1 and positive 4 because those multiply to get negative 4, but they add together to get me positive 3. So if you switch the negative sign on accident, this would be the proper answer. All right, let's look at D. So I will draw my square. I think I'm getting a little better at this. All right, so my C value, or the product, is 21, and my B value is 10. So again, I'm pulling these from my equation, so 10 is the B value, and 21 is the C value. So my factors need to multiply to 21 and add to 10. So let's think about this. 21, I think 7 and 3 are both factors of 21. And I like those numbers because I know they add to get 10. So our answer would be x plus 7 and x plus 3. Because 7 times 3 gets me 21, but 7 plus 3 gets me 10. It's also worth noting, I haven't said this yet, if you wrote it the other way, this is still the correct answer. So since we're multiplying, it doesn't matter whether I write this parenthesis first or this parenthesis first. Because I'm multiplying, that is our, I believe, commutative property of multiplication. Order does not matter in that case. So either of those would be correct. Looking down at problem E. Our variable is now m, so let's make sure we're using the proper letter. Okay, so in this case, my product is going to be 30, and my sum is going to be negative 11. Make sure you keep track of the sign. So negative 11 is the sum, and the product is 30. So if I notice, if my sum is going to be a negative number, but my product is positive, both of my factors will be negative. Because if I multiply two negative numbers together, they get me a positive, which the product is positive, but when I add them together, they will get me a negative. And so we need to, that's a good thing to just notice right away. So with that in mind, we know it has to be, or our two factors have to be factors of 30. So I have 1 times 30, 2 times 15, 3 times 10. Let's see, does 4? Nope. Does 5? Yep. 5 times 6. So they're both going to be negative. So what two numbers can add up to 11? That will be 5 and 6. And you can always double check this with your calculator. So negative 5 times negative 6, that will get me positive 30. And negative 5 plus a negative 6, or negative 5 minus 6, that will get me negative 11. So now that we have all that, we can write our answer. So I will have m as my variable, minus 5, that's one of my factors, and m minus 6, that is my other factor. Alrighty, I want you to try problem F on your own. Pause the video and see what you get. Go. Alright, so this is another case where both of my factors are negative because my product is positive, but my sum is negative. So both of my factors have to be negative. With this case, it's kind of easy because with 7 as our product, 7 and 1 are the only factors. So this is pretty quick to figure out, hopefully. So our answer should be x minus 7 times x minus 1. Alrighty, problem G. We have a product, ooh, that was bad. A product of negative 12 and a sum, oopsies, I wrote that on the wrong line. A product of negative 12 and a sum of negative 3. So, sum of negative 3, product of negative 12. So if our product is negative, what does that mean with our two factors? One is negative and one is positive. So let's list out these factors. 1 times 12, 2 times 6, 3 times 4. So if you look at this one for long enough, you might just get frustrated. This one is actually what we're going to call, for now, unfactorable. So with the given factors, there's no combination of factors that will both multiply to negative 12 and add to negative 3. None of these factors will work. So factoring is not a proper way to simplify this trinomial. We will learn some new methods in a few sections on how to do this, but for now, if you see a problem and you cannot factor it, just write unfactorable. All right, let's look at problem H. I have a product of negative 7 and a sum of positive 6. So negative 7 and positive 6. So once again, I see my product is negative, so I know that one of my factors will be negative and one will be positive. 7 only has one pair of factors, 1 and 7, so we just need to figure out which number is positive and which one's negative. Since our sum is positive, we want the larger number to be positive. So negative 1 and positive 7 will be our factors for this one. So we get a final answer of a minus 1 times a plus 7. All right, there are 2 problems left. I want you to pause the video, work these out on your own, and then hit unpause and see how you did.